Hi, welcome to another episode of the Need Stack. In the past episode, we have built two Docker images. The first is the database, and the second is the application itself. So if you remember, the database is the MySQL seeded with some initial data, and we have also created the database with the schema file, and the Need Stack application version 2 will contains the application image for Nest.js and Angular all running on Node. And we did a simple deployment. Sorry, not this. We did a simple deployment where we use where we created a Docker Compose file, in here, Docker Compose file, and we deployed the application. We tested our two images. So that is well and good, and it is running. In this episode, what we're going to do is this. We are going to use Kubernetes to deploy a slightly more sophisticated deployment. We will deploy a MySQL service on the back end here, and we will deploy two instances of the front end of the Need Stack application of this guy here, and we will create a scaling group to scale the instances as and when it is necessary. That is, when there are a lot of requests coming in, we would like to scale this. We will deploy an ingress to allow traffic into our application, and finally we will set a firewall here, a rule here to only allow traffic from our application, from the Need Stack application to the database. Okay, so this is what we're going to do for the next maybe 45 minutes or so. I'm using Minikube. So this is my Minikube setup. I'm using 8 CPUs and 8192 Mac. I've also enabled the network plugin to use CNI. The reason why we have to use CNI is because we need to install a network solution for the network policies, this firewall part here, to work. And the network solution that I'm using is Cilium. You can find the instructions, the installation instruction here. It's actually fairly simple. All you need to do is enable the Berkeley packet filter, and then just run a YAML file to install, I think, a Cilium operator and some pods and some deployments. Finally, we need to also enable metrics server on Kubernetes. And also you need to enable the Ingress controller. We need metrics server because if we don't enable metrics server, then our auto scaling will not work. And also we need to enable Ingress, for the traffic to come in. So once you have done all that, I won't go through this. It's fairly simple. Once you have done all this, you can verify your installation by first of all doing a kubectl get the pods from the kube system namespace. Okay, so you should see your Ingress. Okay, so this is enable, and your metric server, and also both the Cilium. The operator, the pods, both the Cilium pods are running. The next thing you need to do is just to verify that the metric server is running. You go kubectl top. You can look at the pods. Or look at the pods from all the namespaces. Okay. If you just start the metric server, you may have to wait for a couple of minutes before this matrix will turn up, or you can look at the nodes, right? And the next thing we want to do is this also. We need to check if the Ingress is working. And what you do is this: you go Minikube, you get the IP address of the Minikube's IP address, and then what you do is open your browser and just type that in, and you should see this page. Okay, and the reason why we're getting a 404 here is because the default service, which is handling Ingress, telling us that we don't have any resources deployed, and that is reasonable because we haven't deployed any resources yet. So let's start first of all by creating this deployment. Okay, so we will start off by deploying the database. For the database, what we will deploy is we will deploy a stateful set, a Kubernetes stateful set. So what is a stateful set? Okay, so we will start off with deploying a stateful set. I'm going to assume that you know a little bit of Kubernetes to appreciate some of the things that that I'm doing. To create a stateful set, the first thing we need to do is this: we need to create a headless service. So we will start off by creating a headless service. I'm going to call my the file to define this database, database YAML. Okay, we'll start by creating a service. We say API version v1. The kind is service, and then the metadata. The name of the metadata, I'm going to call it NEATDB SVC. And the labels, I'll just use that labels here. And the spec, okay, so this is important. By default, generally when you deploy a service, the default service is a cluster IP. In other words, the service that's running inside the cluster. And what Kubernetes will do is that Kubernetes will allocate an IP address for this. So generally, services hide a bunch of ports behind it. So for example, in this case, if we define a service in front, the service will actually hide the exact name of the port. You access the services, you access the port through the service, that's the service name, and the service will route the request to one of the, to any of the port that is available, that is to the service endpoint. However, in a stateful service, the service itself doesn't have an IP address. Unlike the regular service, the service itself in a headless service doesn't have an IP address. And what does headless service IP does is this: it exposes the port. So the port becomes part of the service service name. Okay, so we will see. If you don't understand, doesn't matter. We will see. How we do this, and then we will come back and contrast this with our deployment when we deploy the NetApp. So we will say cluster IP. We want to create a service without an IP address, because we want to address the port directly. So we will say none. Okay, and then as usual, the selector for the service. Currently, we haven't. So this one selects the ports label. We don't have the port yet. When you create a stateful service, you need to create. When you create a stateful set, you need to first of all create a service first. Okay. So currently we don't have the port yet. So I need to remember this. So this, I'm going to call the port, the label for the port name, and then I'm going to call it NEATDB. Call it port. Okay. And then finally, for the service, the ports, the name, I will call this NEATDB service port. Since this is my SQL, the port is going to be 3306, and then the target port is the port on the port on the port, okay, which is also 3306. So that's our service. Let's create this. I'm going to create this in its own namespace. So I'll create a namespace. Let me just go into here first. Okay, create namespace. Call it NEAT-NS. Okay, so what we can do is that we can go cube cpl watch get svc minus n NEAT-NS. So I'm just going to watch. Currently, there are no resources, right? So we will deploy this guy into the neat namespace. Okay, so we will see now that the service is up. So let's have a look at the service. Okay, so the selector, we are selecting pods with this label, and currently there are no endpoint because we don't have any deployment yet. Okay, so that is done. What we will do next is we will now create the stateful set that uses this service. So the stateful set is apps v1. We're going to create a stateful set. So you just move this over here. The stateful set is right up here. The deployment replicate RS stateful set. Okay, so stateful set. The kind is stateful set. Metadata. The name, I'm going to call it NetDBSDS, and labels will be the same. Okay, so now the next thing, so stateful set is just like a regular deployment. We will specify the number of replicas. And remember, since we're deploying a relational database, we will deploy one instance. Okay, so if you say 2 instances, then you get 2 separate databases, right? If you want a clustered database, then you need to set it up yourself, and stateful set is a good place to set it up. Another option to do is, if you want a cluster, is to actually deploy a MySQL operator and then use the operator to deploy a cluster. If you're interested, in using a MySQL operator to create a cluster, leave a comment, leave me a note in the comment section, and then maybe in a future video I can set it up. I can show you how to do that. So we got one replica, and then we have to have a selector and match labels. And then the name is going to be NEATDB. So remember, this is the pod. Okay. Again, so far, everything is exactly the same as a deployment. So the next thing that is slightly different from a deployment is this: the stateful set needs to be attached to a service. So you need to specify the service. So you need to say service name, and then the service name will be NEATDB SVC. So this thing here, this name here, is this name. So you need to create the service first, otherwise you get an error. Okay. So now the next thing we want to do is this. The reason why we're using a stateful set is because, as you know, pods are ephemeral. If in this case, if the pod dies and Kubernetes, recreate the pod, since the database, we want the pod to reattach to the volume, to its volume. So the reason why we use a stateful set is because in a stateful set, we can actually create volumes. And when the stateful set is created, the Kubernetes will create a volume and associates this volume, specific volume, with the pod. If the pod dies, and when Kubernetes restarts the pod, that same pod will reattach itself back to the same volume. Also, stateful sets, unlike deployment, are ordered. So every stateful set has a number. Unlike normal deployment, where the pod has like a hash. Okay, in a stateful set, the pod is actually ordered. There is an order starting from 0, and if pod 0 dies, when Kubernetes recreates it, it will get back the same name, and it will reattach itself back to the same volume. So let me show this to you. So first thing we need to do is that we need to create a volume claim template. You can define as many templates in here as you want. So this is just a PVC, and then we will give it a name. We will say metadata. The name, I'm going to call this NetDB PVC labels. Okay, like that. And the next thing we'll do is this. We'll set the spec. Okay, so this is the PVC. We'll say access modes. Read, write once, And the second thing we want to do is this: we want to say the storage class. Where is it allocated from? So we want to have access mode. The second thing we want to say is the storage class name. And the storage class name, depending on your cloud provider for Minikube, so we can find out the storage class name by just typing that. Okay, so for Minikube, the storage class is automatically enabled. If you do a list, add-on list, you can see that the provisioner is enabled. So the storage class name in this case is standard. That's the default. And then finally, resources, request, request, storage, and then let's allocate one gig. So that's my volume. And finally, I will create the pod itself. So this is the pod. Okay, so this is the important one, the labels. Okay, so this NEATDB pod, okay, must match the service and also must match the stateful set. And then and then as before, we have the spec. Okay, and then the spec, we have containers. Okay, so containers, we have name. So call it NEATDB container. The image will be using our image, not GitHub. What is it? Docker Hub. Okay. Sign in. Okay, so we want this NEATDB, right? So that's our image. Again, I've created this image in my last installment. Pool policy. Okay. So we'll say if it's not present. Okay. So now we want to set the name of the MySQL root password. Okay. So for this, I will create a configuration file. So I'll create a config file before I proceed. Okay. So we will create a secret, Kubernetes secret. I'll call it neat secret. Okay, so the data for the secret is, if you remember, the MySQL root password. Okay, so this has to be base 64. So I'm going to go echo -n. Let's call this hello, world. Okay. Don't forget to put a -n, because otherwise echo will put a new line, a /n, and that /n will become part of base 64, right? So you want it to ignore the do not, when you echo this, do not add a /n. Okay, so let's create this guy like this. It's created. So let's check just to make sure. Get secret. Okay, so that's the secret. Let's describe it. Okay, so that's our secret. So okay, so my root password. So that's created. So now we will say the container, the config, the environment from, we will say secret ref, and then the name. Oops. Say the name. The name is need secret. Just to check. Just check that. Okay. Right. So now we will say pods. We'll define the pods. For the name of the pod, I'll just call it NeatDB pod. Container pod. So the container pod is 3306. Okay. So the service pod is 3306, and then the target pod. So traffic going to the service at 3306 will be routed to the pod's pod at 3306. So those must match. And finally, we will mount the volume in a regular pod, right? You first of all have to define the volumes here, and then you perform a volume mount. But in a StatefulSet, you don't have to define volumes because the volume is already here. So all you do is this: you just go volume click mount volume. Sorry, volume mount. I think volume. I can't remember. Let me have a look. Container volume. Okay, pod spec containers volume mount. Okay, volume mounts. Volume mounts. Okay, and then the name. The name is NeatDB PVC, okay, on top, and the mount path is var lib mysql. This is where MySQL creates the database. Okay, I would also like to put the liveness probe. We have a liveness probe. And you have an exec. The action, the command that I'm going to run is mysql admin and ping. You say root, and then we'll say the password is mysql root password. Okay, and we will say we will have an initial delay seconds of maybe like 15 seconds. Initial delay seconds of maybe 15 seconds. Okay, so that's our app. Let's try deploying this. So let's see if there's an error. Okay, so there's one error. The resources request. I think it's request. So it's saying that this is wrong. Okay, so that's created. Let's go and have a look. We will stop this guy. We will go the pod SDS, and then we also want to look at the persistence volume claim and persistence volume. Okay, so notice that the database has allocated, Kubernetes has allocated a volume of 1 gig, and we have created the service. So this is our stateful set. And notice that the pod, instead of giving a hash, it is ordered. So this is 0. Okay, if I've got 2, the replica 2, then the second one will be SDS1, NeatDB SDS1. So let's have a look at the neat space. Okay, so that's created. So let's exec into the container to have a look. Okay, exec container. Okay, so we can go. So notice this is my root password. Hello, that's what we set. Okay, so let's see if we can, log into it. Show databases. So you see our database here, NEATApp. Okay. Select show tables. Select all from keyboard. Okay, so we've got 3 ports, right? So the other thing we want to look at is also the host. Notice that this is the IP of the port, and this is the name, the host name, and this is the fully qualified domain name for our port. In a regular port, in a regular deployment, the name of the port is not exposed, it's not part of the service. This is the service. So generally, if you create a regular service, what you get is to access the port or to access the services, all you specify is the name of the service, the namespace service cluster local. However, in this case, in a StatefulSet, because we have created a headless service, the IP, the name of the port is part of the service. You cannot just access the service because the service does not have an IP address. Okay, so you need to access through this. So when we configure the database later on in our application, we need to give this whole thing rather than just the service. Okay, so that's the first part of our application. We have created that database, okay, and we can access it. We know that it's working. So the next thing we want to do is we are going to create the application itself. So the way the application is different from the database is this is going to be a regular deployment. So I'll create the application. I'll put it in a separate file. So this is the application. We will start off by creating a deployment. And the kind is deployment. The metadata. The name of the metadata, I'm going to call this NEATApp deploy. The labels, this guy here. And now the spec, okay? So the spec, the replicas, I want 2 replicas. Selector, match labels. Okay, and then finally, we need to specify the template. Notice that we don't really need for deployment. We don't really need the service name. Okay. Okay, so we will say metadata. So the name is going to be NEATApp deploy. So the labels will be this label, and this is important again because we are saying that the selector any port with this label belongs to this deployment. So this has to match with this guy, and then finally we have spec containers. Okay, so I'm going to call this NEATApp container. Image name. The image will be this image, but we're going to use version 2. NEATApp. We're going to use version 2. And the image pool policy, only if it's not present. Okay, so now we're going to configure our application. So again, we're going to use config file. So let's go back to the secret config here. We need a few configurations. First of all, we need the port number, we need the database host, and we need the database host, the database user, and also the database password. Okay. So again, go back and have a look at the source code. The database password is for the application is specified by db password. So the password is going to be the same as this. And then finally, we will create a config file. Config map, not config file. And the data, we're going to need a few things. We're going to need port. Okay, so this is the port that our application is going to expose. Remember, these are web app. I'm going to set port 8080 as the default port that's exposing. The next thing I need to do is I need to go db host. Okay, so the db host will be this guy. Okay, so it will be need db sts 0. That's the name of the port. The name of the service is need db svc. The names, that's the service name. Next, followed by the namespace, need ns, and then svc.cluster.local. Okay, and finally the db user is root. So let's go back and add our environment. The first one is going to be config map ref. The name is going to be need config map. So this is the config map. So it's going to read all this. So I haven't created this. Let's create this guy first. Okay. So again, let's check. Okay, so that's the config map, and that's the secret. Okay, so we have got host, the user, the root, the port, and then the secret. Okay, so we've got two secret. They are exactly the same. Okay, so we got one of that step, and then we will create the other one. Secret, okay. The third thing we need to do is that we need to create ports. We need to define ports. So I'm going to call this NEATApp port, and the container port in this case is so remember we are exposing port 8080. Okay, container port, and we want to also provide a liveness check, liveness probe. Okay, liveness probe. Let's see. Exact command, and then we're going to use a curl for this, right? Curl localhost 8080 API HALPH set. Okay, and this one we want to say, maybe initial delay seconds. Again, 15 seconds. Okay. One last thing I'm going to do here is this. Because we are going to use auto scaling, I need to tell Kubernetes just how much resource is this is my pod consuming. So for example, I need if you're going to scale like based on either CPU or memory, then you need to specify what is the minimum that the pod requires. Otherwise, it will not be able to scale, because if you don't tell it, what are the resource requirements, the autoscaler, cannot determine, when it should actually scale. So let me just make sure I get the indentation correct. Okay. So this one, again, it's the same thing. Like we are allocating resources. So we'll say resources, right? So under resources, there's two, right? There's request and there's limit, right? Request is the minimum amount. So we need to set the minimum amount. Okay, request. Then I would say like CPU, maybe 100 M, and memory, maybe it requires 128 meg. Okay, so that is my application. Let's run this and see. Let's try this out. Okay, so let's come here and we will add in besides STS, we'll add in also the deployment. Okay, so that's up and running. So let's have a look at the logs just to make sure that we get everything correct. Okay, so notice that the ping, this is the ping is working. Okay, and it's doing like, I think like every 30 seconds or something, the default. We can exec in. Okay, so that's, I've exec in, and I can actually ping, let me see if there's a ping command. Okay, I can actually ping the name of my database, need db sds0 dot need db svc, I think need ns svc service cluster local. Okay, so notice that it's pinging from there, and I can also test out my port by doing a port forward. And if you remember, our internal port, the container port is 8080. So let me expose this to 5000. Okay, so I'm forwarding 5000 external to 8080 internal. So let's try our application. 5000. That's our application. Okay, let me clear this in case in case it has cached the application. So let me just do that again once, and then we can access. So that's my database. So the cluster is working. The deployment is working, and we've got two deployment. So we know that ports are ephemeral. Let's create a service in front of this guy. So in this case, we are going to create a regular service. We're going to create a regular service, and what the service will do is this: the service will allocate an internal IP. It will not be exposed externally. Later on, we will create an ingress and we attach ingress to our service. So the next thing we will do is we will go and create our service. Okay. Kind service and the metadata NEATApp service, and then I'll say labels the same, and the spec, right? So the service type is cluster IP. Okay, I want it to allocate an IP address, and this IP address is not accessible externally because it's cluster IP. It exists only inside the cluster. Then I will say selector. What are the ports that belong to this service? What are the endpoints? I'll say name. Then the NEATApp port. So it's this name. So make sure we get it correct. Okay. So I made a mistake here. Notice. Okay. So I want this to be. Okay. I want this to be port. Okay. So let me delete this guy first. Okay. So let me just make a copy of this. Okay, I've actually labeled it wrongly. I mean, it doesn't matter, but I want to correct it so that so that we can be clear on what we are doing. Oops. Okay, so let me just do this. So this is incorrect. I mean, in my case, is incorrect. This should be a port. Okay, so that's not so important. This is the important one, right? Okay, so let's deploy this again. So let me just do this, right? Let me just put an O white here so that we can see more information. Okay. So that's my port. So let's go back and bring in what I've done just now. Okay. Right. So this is what we have. We are selecting that. And finally, we'll say ports, the name of the port. So let me just move here. The name of the port, I'm going to call this NEATApp service port. Okay. And I'll expose it the same port number as a container port, 8080. Right. So we will say the target port is NEATApp as so that's the name. So we are referencing. So we're using the name, this name. Okay. So let's create this service, and we see that the service has been created. The NEATApp service has been created. The selector is NEATApp port. Let's look at the endpoint for this port, and the way we're going to look at this, we're going to say kube describe service NEATApp service. Notice that the endpoint is 2, so it's 10.0.0.160 and 10.0.0.4. We can go back here and have a look at the two thing. 10.0.0.160 and 10.0.0.4. These two port is the endpoint for is the endpoint or the upstream for the NEATApp service. We can also test our service by doing a port forward. So now, rather than port forwarding to a specific port, we will port forward to the service. Okay, we'll say service NEATApp service. Okay, again, we will keep port 5000 and we'll keep the local host, so external port, internal port. And then we will, I'm just going to clear the data again, and we'll run this again. Okay, so now the data is coming from, this is now the service. Okay, and so the service redirects the traffic. The service redirects the direct the traffic from my port, from a port forward from the request over to one of these two instances, right? And then the instance, access the database through its service. So this is what's happening. Okay, so this is now good, and the application is now running internally inside my cluster. Now, time to let traffic in from the external world. Okay, so in other words, I want to access the traffic using the IP address of Minikube. In a real world deployment, when you deploy, an application, when you deploy your application into Kubernetes, let's say on DigitalOcean, on AWS, if you have Ingress, what is going to happen is this: the Kubernetes will ask through an interface layer, will ask the native cloud provider to typically provision a load balancer, an external load balancer, and the load balancer will have IP address, and the load balancer will direct all. So when you make a request to the external load balancer, the load balancer will redirect traffic into the cluster. Okay. So what we'll do is this: we'll now create an ingress resource. Remember, to use ingress in Kubernetes, you first of all need to enable ingress. We are going to enable ingress by doing this. So stop this guy. So ingress is networking. KASIO. Ingress is v1. Okay, ingress is v1. And then the kind is ingress. And the metadata, I'm going to call this NEATApp ing. And the spec for this, for ingress, is we need to give the ingress class name. I know that for Minikube, the ingress that they are using, the ingress controller they are using is actually the Kubernetes, the Nginx ingress. It's this one. Okay, it's this guy here. So actually it's this guy here. Right, so it's this guy here. So this controller, and the name of this controller, is Nginx. You need to set the name. Actually, you don't need to set this name because I've only got one ingress controller. Like, for example, in cases where in Kubernetes, in cases where you got like a few ingress controllers, like maybe you've got an Istio installed or maybe Kong, then you need to say which of this ingress controller you are deploying your ingress resource to. Okay, so I'll put it here for completeness sake. This Nginx. Then the next thing you need to do is that we need to define a bunch of rules. I'm not going to set TLS. The next thing we're going to set is rules. So rules is actually an array. You can specify host. In this case, if you support virtual host, you can specify host. In this case, I want all my traffic to go to this particular deployment, so I'm going to leave out host. So it's going to be a wildcard. The next thing to do is HTTP. Okay, and path. So path is an array. Okay, the path. What is the path? I'm going to match on path slash. Then the path type. This is the matching. How it's matched. So this is the prefix match. So just match the prefix, right? So in other words, anything that starts with slash followed by whatever, right? It's going to be routed to this backend. Now the name of the backend, it must be in the same namespace. It's a service. Okay, so the name of the backend, in this case, is NEATApp service. Okay, and the port, okay, it's going to be a number. The reason why I'm not using the name, you can actually use the name, but in my case, so the name is going to be this name. In my case, the length of the name is greater than 16 characters. So if I use name, Kubernetes will give. I'll get error when I try to deploy this. So I'm going to use the number, and the number is according to mine is port 80. Okay, and since it's ingress, I can also do a few things. I can add a. I can do things like I can enable calls if I want to. I can set I can set rate. I can limit. I can do things like rate limiting. So let me just show you. So I'm just going to specify the rate limit on this particular resource so that I don't have so that so to prevent like things like DDoS attack. So this is so I'm going to use this guy here, and I can set like whatever how many requests per second, and if the request per sec from a single IP address, and if the request per sec and if the that IP address, the number of requests from that IP address exceed my the threshold here, then it will get a 503. So to set the rate limit, these are annotations. I'll go back to the annotations here. Oops. And then I'll just say engine INX, Ingress, Kubernertes, IO, limit requests per second. So let's say requests per second, I want like maybe 5. Okay. Now let's deploy this guy. Okay, so that's deployed. Let's have a look at our Ingress resource. I don't need the PVC anymore. I'm just going to delete that and just look at our Ingress. And that's our Ingress. We can get more information from our Ingress by doing this. Sorry, what's the name? NEATApp Ingress, right? Let's see why. Okay, I spelled incorrectly. So let me change this thing. Okay, I'm a little bit yeah. NEATApp, NEATApp. Okay, so I have a certain way of naming my resource so that I don't run into I don't run into problems. So I like to fix it. Okay, let's see. My Ingress is up. Okay, NEATApp. So let's have a look at describe. This is the Ingress. All from all hosts, anything that starts with / will be routed to the NEATApp service port 8080. And so this service has 2 backend, right? So we have seen the 2 backend. We've got one annotation with his number of requests per second. Now we can access this application using the IP address, using the Minicube's IP address. So in your case, if it's in a real deployment, then you probably need to get the IP address of the load balancer that this Ingress controller is deployed against. So that's the IP address. This is the IP address, right? So this is my application now. So let me just click again. Let me clear it so that I'm not running from. Notice that there is no cache because there's no HTTP. So the service worker is not installed. And we get our data. Okay. Right. So we have done this part. We have done Ingress. Next thing we'll do is this. We will install. We will create an auto scaling group so that the application will scale. The Kubernetes will scale the number of pods depending on certain matrix. Again, just a word of reminder: if you want to use auto scaling, you need to first of all set the resources on your pod. Let's go and look for the auto scaling. We're going to use the horizontal. Since our application is stateless app, right? It's a web app and it's stateless. We want to scale horizontally. We will get it to scale horizontally. So we will use the horizontal pod autoscaler. Horizontal pod autoscaler. We'll set here auto scaling. It's got a few versions. I'm going to use the newer version. So this is V1, right? I'm going to use the V2 beta 2. And then the kind is horizontal port auto scaler. And then the metadata the labels, call it horizontal port autoscaler. And now the spec, horizontal autoscaler, we will set the mean and the max replicas, how many replicas we want. We say maybe we want to go up to 4, okay? And then the next thing we will have to set is the scale target ref. What exactly are we scaling? We are scaling a deployment. Scale target ref. So you need to say the API version, what kind is it, and the name of the kind. So our API version is apps v1. The kind is a deployment, and the name is NEATApp deploy. That's what we are scaling. So remember, currently the number of replicas we have running for the deployment is 2. Okay, but I've set the minimum replica to 1. Okay. The behavior, this one controls, the scaling up and scaling down. I'm going to leave this. Finally, the last thing that we need to set is the metrics. So the metrics, we are going to scale based on the resource. Okay, and we'll specify the resource here. So the name of the resource, okay, so CPU. So the name here refers to these things here, the request over here. Okay. Generally, I find that CPU is not really a problem because ours is a web app, so it's not really CPU bound. But perhaps it's but more often than not, it's memory that's causing the problem, especially with Node application, and you have really large requests. Sorry, when a request comes in, your middleware, the Node middleware, in this case, Nest.js, maybe pull a lot of data from the database, do a lot of things. So the average memory per request can be quite high. So in this case, I may want to scale it based on the memory utilization. I'm going to put in both of them. I'm going to put in both the CPU as well as the memory. So the target, the type, I'm going to say average utilization. Type is utilization, right? So utilization, and then the average utilization. I'm monitoring the average utilization. So let's say 80%. Okay, and let's do another one. In this case, this is memory. Again, the utilization is 80%. Okay, so let's apply this guy. Oops. So that's an error here. Auto scaling. Unrecognized version. Oh, sorry. It's a slash. Okay. Missing field. Max replicas. Okay, so let's go and have a look at our autoscaler. So we specify that the minimum port is minimum port is 1, the maximum port is 4. Notice that the current replica is 2. We're going to leave it a while. We're going to come back to it later. What the horizontal autoscaler will do is just it will reduce the number of 2. Currently it's over because we are not over the threshold. So the autoscaler will bring this number of replicas down to 1. You automatically set it down to 1. So we'll leave it for the time being first, and then we'll come back to this. We have actually completed our application, our configuration, or the setup on the application side. Finally, the last one, what we're going to do is that we're going to set the network policy where we say that only requests from our NEATApp pods can access the database. So let's go back to the database, and we are going to specify. We're going to specify the network policy. Okay, the network policy. Remember, for network policy, by default, Minikube doesn't support it. You need to install a networking solution. That's why you need. That's why I have used the network plugin CNI and add a network solution like Cilium. So we'll say API version, and this is going to be networking KASIO, and the version is v1. Kind is network policy. Okay, and then the metadata name is NEATDB netpol labels. Okay, so now we need to specify the rules. The first thing we need to say is what type of policy we are defining. So we are going to define ingress rules. Okay, we're going to define ingress. So why ingress? Okay, for network policy, right? So in other words, so let's look at this. So we are going to say, just assume that we're standing on the database here, and we're going to say which pod is allowed to access the database. Okay, so from our point of view, if you're standing on the database, the direction of the traffic coming in is this way, right? So it's ingress. Okay, so that is why the policy type is ingress. Okay, now we need to say what is the pod, the location of our person standing on. So ingress in relation to what? So that is where the pod selector comes in. So the pod selector, it's like the service. So if you recall, DB pod. So we are saying the ingress rule will be applied to any pod that's matched this label. So we are saying this label. So this is the same as the NEAT. Okay, same as the service, right? Okay, it's the same as the StatefulSet. Okay, so we are selecting the pod. We are selecting this pod, and we are saying the rules that we're going to define are ingress rules. So now we can say ingress. So ingress is an array. Ingress has got from and also what pod it can access. So there's two things here. There's a from. From is an array. And we can select an IP block. We can select a namespace. We're going to do pod selector. Again, this is match labels. And we are now going to select our NEATApp. So the NEATApp is NEATApp port. Okay. And finally, we need to say what port we are opening up. What ports we are opening up, and the port number. So port, since we are opening up port 3306. Okay, or in this case, since this is less than 16 characters, we can say need db port. So this guy is referring to this port here. Okay, so let's deploy this. Network policy has been deployed. So let's look at the network policy. Right. So that's my network policy. Okay, so before I look at network policy, notice the auto scaling. The number of replicas is now 1 because we say that, you know, for our scaling policy, we say that the minimum number of port is 1, and since, you know, our application is not really stressed, quote unquote, the HPA has scaled our application down to the minimum number of replicas, which is 1. So notice there's only one here. And if we go to our service endpoint, you'll notice that there's only one endpoint. Okay, so finally, let's look at the network policy. This is our network policy. We are selecting, this is our port, the database, okay, and only traffic from this port with this label can access the NetDB port through this port TCP. Okay, so this is 3306. Let's run this application again and see what happens. Okay, so you can do that, right? So let me do something. Let me go and change this, and let's say that, you know, like let's say like I make a mess, and I, you know, just do that. So let me apply this again, and just to make sure. So notice that the port selector is this now. So let's try accessing this again. Okay, and we go this now. Notice that there is no more database. I can't access the database, and if I try to do it, the server actually crashed. I mean, my application actually crashed. So that is the end of this episode. That's the end of this episode. It's quite a long episode, and there's a lot of Kubernetes, a lot of YAML file. Thank you for being patient. Please do have a look at the Kubernetes. If you got any questions, you know, please leave them in the comment. Otherwise, you know, enjoy the rest of your holiday and Merry Christmas.